Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to talk about VIO, VMware Integrated OpenStack, and NSX. How a VIO is an easy button for OpenStack deployment, also with the NSX providing the network. So here we're going to talk about the architecture, the VIO architecture. In the middle, have VIO, and it will be consumed by Horizon. That's the project that provides the user interface, the UI interface. We're going to consume our infrastructure as a service. And in the back, we have the VIO products. We have Nova for computing, and in the VMware world, the Nova will be provided by vCenter and ESXi. Here we have a benefit of using VMware as our Nova project because vCenter will be the single endpoint for all the Nova workloads, and also have like native VMware features like DRS and vSphere H8 that helps with the availability of the environment. And we have Cinder as the block storage. In the VMware world, Cinder will be provided as our data store. So every time that we use a data store, it will be used as a Cinder block storage. Neutron will be provided by NSX. Like Nova, NSX has a benefit that will be the single endpoint to deploy networking, like layer 2 switches, routers, load balance, and firewalls. We also have Glance. Glance is the image project for OpenStack, and in the case of VMware, the Glance will be the VM templates that will be used and that will be consumed in VIO. So before we start, we need to deploy some objects in NSX. In this case, we need to deploy a T0 router, and also we need to exchange the routes between T0 and a physical router using BGP. This way, everything that we deploy in VIO will be automatically distributed to the physical infrastructure. So after that, we're gonna have our first step, that is to create a local network. In this case, we're gonna create a local network called local 1, and we're gonna connect two VMs in that network, Web 01 and Web 02. So here I have our network topology. I'm gonna create the local one network, create a subnet for that network that's called local 1 subnet, and also provide the IP address for that network. And it will automatically use the first IP as the default gateway when you create that. And now we're going to connect our Web 01 and Web 02 to that network. Web 01 already connected, and now we're going to connect the Web 02. And now I have already layer 2 connectivity between those VMs. And I'm gonna connect to the Web 01. It asks for changing password because the first time that I connect to that. And now I'm gonna ping to the Web 02. And you can see here that the ping is working. So the second part is to create the routing network. So to do that, we're gonna create a router in VIO in the NSX, and like under the hood, what will be done is NSX will be configured to create a new T1 gateway, a new T1 router, and also we're gonna use the T1 router to provide connectivity between the local one network that has just been created, and to local 2 network where we're gonna have our other VM that's at O1. So here in the routers tab, we're gonna create a new router here called VIO router. And then we're gonna access that router and go to interface, add a new interface, select the network that will be connected, and it automatically will use the first IP as the IP for that router. And that will be our default gateway. You can check in the topology that will have our router connect to local 1 and local 2. Now I'm gonna connect the Apple 1 to that network. Apple 1 is already connected to the local 2, and it gets its IP address automatically using the HCP. And if I do a little ping here to my WebO2 or to my Apple 2, the ping works successfully. The third step is the external network. So the external network is kind of an IP pool that will be used as a floating IP or like external load balance IP. It doesn't create a real network. It creates a pool that will be consumed either as a floating IP or a load balance IP, but it doesn't create anything. In this case, that external network will be used by this T0 to provide NAT or to provide or to deliver those IPs to our objects that will be published externally. So as it's an external network, we need to do that in the VIO admin level. So this way we can share that network with among all the projects that we need. So I need to go to the admin level, go to network, and here I'm gonna create a new external network. I'm gonna call that network external, select the project, this way, in this case will be admin, and it's a local network, but I select here shared and external. I include here the subnet name that will be used as our pool name, and also the IP address that will be delivered to that pool. It doesn't have a gateway. It doesn't have a gateway now, neither DHCP. We cannot create DHCP. We cannot set the DHCP rules in the external network. And here we can check that our external network has already been configured. The fourth step is the floating IP. So the floating IP will be done by connecting that T1 to our T0. Actually, you're gonna connect that T1 to the external network. That what is showing. That's what is shown on the VIO console, and it actually is will distribute the floating IPs that we assign to the VMs here. So when you create that, it will create a source NAT rule to all those VMs communicate with an external, with an external network using a source NAT IP, and also to the ingress traffic, the traffic that comes from the external, like the physical network. We need to provide a floating IP to those workloads. This way, we don't need to redistribute or to share the internal networks with like a physical network. It helps a lot when you have like bubble environments or when you have a multi-tenant environment and you have IP overlapping. This way you can have multiple identical networks with identical subnets sharing only the floating IP as a common network. So this way we're gonna go to routes. It has to be done. It has to be done in the project level. And here in the VIO router, I select my external network as my source, my way to the to external world. And here I can see that all the networks can communicate externally, and I'm gonna create a floating IP. So I have 50 floating IPs available. I'm gonna allocate one to my project and associate that floating IP to my VIO1. After associate that, I can successfully do an SSH to that VM. And here I will log in and try to do a little ping to my app VM, and the ping will work as it worked before. The fifth step is the load balancing. So we're gonna create a load balance that will be placed in the T1, and our pool members will be VIO1 and VIO2. So I also need a floating IP pool to do that. That IP pool will be associated to our load balance later. I go to Neutron load balancer, create a new load balancer. I can select here a name for that load balance, select which subnet will be connected, the load balancing protocol, that in this case will be HTTP, also the port that will be used, and the method, in this case will be round robin. Here I select the pool members, that will be VIO1 and VIO2. Also can select the port if it's another port, the monitor. I can select like get to a specific URL or an object. And it's really simple to create a load balancer. After that, we need to associate that load balancer to my floating IP. And once that's associated, we can connect it to our network, to our application that's running in that network using the floating IP. You can see that's load balancing across VIO1 and VIO2. The last step is the sixth and last step is the security group. So security group will be delivered by the NSX DFW. So in this case, we're gonna create a new security group called allow HTTP and block everything else. It will allow external, like ingress traffic to HTTP, like to a web application, like Apache or any Nginx. And I will associate that security group to my VIO2. That my VIO2 is in the full security group now. If I try to ping my VIO2, it works. And if once I change my security group to allow HTTP and block all and remove the default, I can check here that the ping is no longer working. So I can see the packet drops here. And that's all I have today. Thank you very much for watching. See you next time.